Welcome back to another exam walkthrough. We're going to be going through 2019 October, question 13, part A. You can pause the video, try the question out yourself, and then watch me solve it. For the MS and the examiner reports, you can go to the end of the video. Okay, so question 13 says a photograph shows an area of land where golfers can practice their golf shots. Distances are marked out along the land in front of where the golfer stands to measure the distance traveled by the ball. Two levels are available. If the lower level is used, the ball lands at the same height from which it was hit. If the higher level is used, this enables the ball to be hit further. Part A says, a ball is given an initial velocity of 33 meters per second at an angle of 28 degrees to the horizontal. When hit from the lower level, this ball travels a horizontal distance of 92 meters before landing. Use of the higher level increases the horizontal distance traveled before landing by 10 meters. Deduce whether an upper level at a height of 4.5 meters would be sufficient to produce this increase. You should ignore air resistance. Okay, so let's try to understand this question. So when you play golf, you can either hit the golf ball from the ground. And when you hit it from the ground, you're going to launch it. And when you launch it, it's going to travel a horizontal distance of 92 meters. The question says that when you hit it from the ground, it calls it the lower level. Okay. Now, if you want to maybe throw it a bit further, you want the ball to go more than 92 meters. So you're going to go on a higher level. Okay. You're going to go on a higher level and the ball is launched. Now, maybe it can go 100 meters, 120 meters, okay? But the distance has to be more than 92 meters now because you're launching it from the top, from the higher level now, okay? So, or the upper level, you're launching it from the upper level now, okay? So, that's kind of what the question is saying, okay? Now, the question is saying whether this upper level being 4.5 meters is enough to cause the distance, horizontal distance, to be 102 meters. Okay? Because what the question says here is that use of the higher level increases the horizontal distance traveled before landing by 10 meters, which means now our horizontal distance is 92 plus 10, so 102 meters. Okay? Now it says, deduce whether 4.5 meters is enough to cause the horizontal distance to be 102 meters. Let me just write that down. Is a height of 4.5 meters enough for horizontal distance to be 102 meters? That's basically the question, in short. Okay, so again, lower level, 92 meters. Higher level, it goes beyond 92 meters. We want to see 4.5 meters is enough to cause the horizontal distance to be 102 meters. Okay? Right, so let's plug in some values here now. So we've got this as 33 meters per second. Actually, before we go further, let me just erase some stuff so we have a little bit more of room. Okay, now we can say that this is going to be, let me erase this as well. Let's put this here. Okay, so this angle was 28. Okay, so 28. This is going to be 33 cos 28. It's going to be 33 sine 28. Up is positive, down negative, like usual. So ux is equals to 33 cos 28. uy is equals to 33 sine 28. Okay, that's going to be 29.1 meter per second. That's going to be 15.49 meter per second. Okay, so we have done that and we've labeled the directions. Now, what I'm going to do here is, we know that the horizontal equation is Sx is equals to uxt. Okay, Now I'm going to see, listen to this very carefully, okay? You can do this in many ways, but I'm going to try to do it the easiest way and the quickest way possible, okay? I'm going to see the time taken for me to go from A to B on the ground. Okay, 1 second. Time taken to go from A to B, which means from the upper level to the ground. Okay, so from A to B, I want to find that time. How much time does it take? When I'm at 4.5 meters above the ground. I repeat again. I want to find the time taken to go from A to B when my height is 4.5 meters. And I'm going to remove this and call this distance D. This is what I want to find out. Okay. Now to find that distance D, let's call this distance D. Okay. I already know UX. I want to find the time taken to go from A to B. That's the main thing. Okay. Now what we can do here, there are a couple of ways to go about this. The easiest way is we want to find first the displacement to go from A to B. What's the displacement to go from A to B? That's going to be the displacement at B minus displacement at A. Basically, we're finding the change in displacement. This is going to be my zero displacement. And then this is going to be my displacement minus 4.5 meters. Okay, because I go below zero and down is negative. Okay, this is zero. I'm going below, down. So my displacement is down. I already told that down is negative. That's my sign convention. Okay, so my displacement at B is going to be minus 4.5. Displacement at A is equals to 0. So my displacement AB is equals to minus 4.5. Now I could have just written this, but I want to make sure you understand all of this. Okay. Alright, so that's my displacement. Now we do our SUVAT, S, U, V, A, and T. U is going to be 15.49 meter per second. V, we do not know. Acceleration is going to be minus 9.81. And time, I want to find out. So we can use the equation S is equals to UT plus half AT square. Okay. So let me plug in the stuff now. So when you plug in the values, you're going to end up with a quadratic. You can plug it in the calculator and get the two values of T. So T1 is equals to 3.425 and T2 is equals to minus 0.267 seconds. Time cannot be negative, so this is wrong. And this is going to be my answer. Okay. So that's going to be my time. So now all I have to do, T is equals to 29.1 times 3.425. So that's going to give me 99.6675. We can say that's going to be 99.7 meters. So this is going to be my horizontal distance D when my height is 4.5 meters. I hope that's clear. Now the question says that using a higher level would increase my distance by 10 meters. So my distance should have been 102. 102 minus 92 is 10 meters. So using the upper level should have increased my distance by 10 meters. But we can see that using an upper level, which is of 4.5 meters, is increasing my distance by 99.7 minus 92. That's going to be 7.7 meters. Okay. So you can say 7.7 is less than 10. So 4.5 meter height is not enough. Okay. So I hope that's clear. Now I do want to move on to the next part as well, but I want to show you one more way to do this question as well. Now another way you can think about this is that what would be the vertical height HV, or let's just call it H, what would be the vertical height H needed so that our horizontal distance is going to be 102 meters. So the first thing we can do for this one is we know that SUVAT. Okay, we need at least 3 things from here to be able to get an equation and solve. Let's see what we know. Now, we know that the initial velocity in the y direction is going to be 15.49 meter per second. We know acceleration due to gravity is minus 9.81 and v is equals to question mark. Okay, and then t is the time of flight, which we also don't know, and this is the main thing that we need to find out. The best way to do this question is going to be to use the time. You can find the final velocity as well, but that would be a bit too long. Okay, so we know Sx is equals to ux t, and from this actually we can find the time. We know Sx is 102, ux is going to be 29.1, and that's going to get us 3.5 seconds. So time is 3.5. And now we can use an equation. S is equals to ut plus half at squared. So that's going to be 15.49, 3.5, half minus 9.81, 3.5 square. And that gets us a displacement of minus 5.87 meters. And we can clearly see that 4.5 would not be enough. So 5.87 is greater than 4.5, so not sufficient